Let's go to LeetCode 366. Find the leaves of binary tree. For this question, to give us a binary tree, and let's return this list of integer. So for this question, it need to put, for example, when we find a leaf, 4, 5, 3 into one list, and when we get rid of this kind of leaves, and it left 1 and 2. So 2 is the second layer of leaf. So we'll put 2 in the second list. And when we get remove the 2, we'll get leave, it will left 1. So 1 will be another layer. So what we think about this question is that we need to have some kind of post order traversal for the tree. And when we do the post traversal, this kind of traversal we call, for example, we have a function called DFS. It return the depths of the leaves. So what the depths mean? So for the leaf, we say that the depth is 0. And if it's none, right, we set this one as -1, and leave that is 0. Then we get rid of this one, and if we DFS to the post tree traversal, we are passing the depth of the left child and the right child, and the current the depth, so that will be the maximum left and right +1, right? And when we go to this kind of node, we try to find, we use a possible map, right? Map as use the depth as key, and value of a list of integer, right? So if it contains key, then we just add the values to it. Does not contain, then we just add a list, and then add this value to it. In the end, for the maps values, right? We convert to list of lists. That will be the result. So let's begin to write code for this. So we are going to have a map of integer list of integer as map, right? So new hash map. So what we're going to do is post order traversal. We have root and the map. What we need is that return new array list map dot values. So this DFS will return an int. So it will have a tree node as one parameter, and also the hash map. It's map parameter. So let's say if this node equals to none, right? What we do is that we just return -1, right? And for this one, we don't need to put it into any map or list because it's not required to have a none into it. So what we do is that we'll have the left result, right? Left result, or left depth, depth equals DFS node dot left map. And then we'll have right depth equals DFS node dot right, and the map. And so for the current one is that into current depth, right? Current depth will be max dot max left depth, right depth +1, right? Then we use a map compute if absent, right? So for this kind of depth, if it does not have the array list, we just create the array list, new array list. Then we need to add this node dot value, right? In the end, just return current depth. Okay, it will be O(n) time complexity for the post-trade traversal, and we use a map that is O(n) time space